Greetings and welcome back again to another functions episode. We're going to be looking at some of the gun basics as well as looking at a generator and starting the very basics of it. I'm pretty excited for the generator because we're going to be learning a new programming, kind of new programming language for me, maybe a new one for you. So let's go ahead, get started. Okay, so here we are in my test world, and I just enabled the armor stand casting data pack. This can be area effect cloud too. I just called it armor stand casting, but it's just right click and you shoot once. So the basics of this is actually covered in my raycasting video, and I'll try to remember to put that down in the description. If not, feel free to remind me. But what we want to do is reuse this mechanic and have a generator for different weapons. And I want it to be very customizable so that a lot of people can use it. So let's get started looking at the generator, and well, we'll go from there. So here we are in Atom again, and we're going to be starting the very basics of the blaster generator. What do we call the main file? Well, let's call it generator.javascript. So JavaScript, I find it the easiest to use because of the way I program, and I like having just a preset instructions file that's in JSON. And so basically it stores all of the information rather than having to type it in each time. So we've got, let's say we've got a guns list, and basically it's got just different types of guns inside of it. So each of these are objects. We've got guns, pistol, rifle, shotgun. And we can add more inside of these, but I'm not going to worry about that right now. I'm going to start the very basics of the generator.js. So let's just do a simple console.log greetings world and see how that works. So the way I set this up, instead of noding it each time, I just create a file and it's just run.bat. And all it does is just node the node, which is node is what runs the function. It's like a server application. So if we go into this folder, we see run, and you saw it there for a very split second. It says greetings. It's really hard to see, so instead of just leaving it like that, I also add a pause to this. The pause, what that does is when I run it, it just stops, waits. Think everything ran correctly, I just press a button. Simple as that. So I think what we should do is create a time object that we can use throughout the application to determine how long something takes. So I'm going to do a little bit of research and then come back when I find something that'll work pretty well. Okay, so what we've got so far is some pretty interesting stuff. I created this class time, and we've got a constructor that has basically no arguments. Constructor has no arguments, and all it does is it sets the startup time to a new date. Then I've got this function called portal, and then it has argument of flag, and basically all it does is it says if the flag's already been set, then tell how long it's been since the last flag of this name, else set that flag. So what this does is it takes the time and sets it to the flag. So we see that here. When the flag is called again, then it runs up here, this part of the if statement, and then it works out how long it took between the creation of the flag and then the end of the flag, and then it spits out a time in milliseconds. So you get the flag name and then how long it took here. Okay, and then after that, we just have a print total time, and that just takes the current total amount of time it takes from the very beginning of the file to wherever this is called. So none of this is actually necessary for the functionality of the program, but it'll help optimize stuff. So if we come down here, so we start with the constant time. This is how we start up the class, and then we create a greeting flag for a portal, and then the end of the portal is right after this console.log. So after that's been spit out, then it'll end the flag, and then that's how it calculates the distance between the time between this execution and this execution. And same thing with down here, it's just a different flag. It could be the same flag because the previous flag has been deleted, but we can use these flags as ways to create organization. So here's the loop, and then down here is another loop, basically like an opening bracket and closing bracket. We don't have to time everything, every section, but I want to time at least the major sections. And then at the very end, we just have print total time. So that's the total amount of time. So if we execute this, we'll see it spits out greetings world, that's the actual output, and the greeting took 3 milliseconds to complete. So, and the loop took just 0. So that makes the current runtime, or at the very end of the file, 3 milliseconds. So it's not too bad. If we really take a lot of optimization out, and let's say this loop was actually a very large number, and then we run it, we'll see that the loop took a whole lot more time. It took 27 milliseconds before it took 0 milliseconds. So sometimes there's like a fraction on top of these, and they get added together. It gets rounded down on both of these, but together it's actually more here. So now we can say, hey, the loop part is taking up a lot of time. Let's optimize that. Well, we don't need the loop to be 50 trillion or whatever that number was. We can just make it 50, and now it's 0 again. So this will be pretty interesting in terms of optimization. Okay, so now that we've got that all out of the way, let's start now with some requirement statement. I usually do constant fs equals require and then fs. That one's very important, or at the very least it's very useful. So this is file system, and that allows us to read and write files. So because this is a generator, I don't bother making everything asynchronous, but I make everything synchronous. So the amount of runtime doesn't matter too much, how efficient this thing is, but try to optimize it. I don't like writing asynchronous because they're just a lot more difficult, and it's just so much easier if everything's synchronous. Anyways, let's go ahead and ignore, yeah, see it says time is not defined because time is defined below it. So we got to create that. We'll eventually move this to its own folder, but for now I don't really care that much. So put both of these constants here. Instead of greetings world, let's just have reading instructions. This actually, the flag is kind of interesting because it might be able to be like that. It might not like it. Let's see. No, it worked perfectly fine. Interesting. So yeah, let's just do fs dot read file synchronously, and that would just be instructions dot json. I can't remember if we need to stringify them or parse them. It might be parse, actually. I think it's parse. We can check with console.log. So now if we run this, it should print out the instructions. Okay, so yeah, we can see the guns object right here. Later, we're going to actually cycle through all of these. There's going to be some big things that we can do. So that took about 5 milliseconds to read, apparently. So yeah, now we have the instructions readable. Okay, so we got pretty far today. We've got the instructions actually printable, that gets printed to the output. Instructions here is roughly the same as this. It's not organized super well, but it's perfectly fine. We've got the timer, which is very useful. All of this is going to be useful for seeing the efficiencies, or most likely inefficiencies, in my programming. I'm not the most efficient programmer. I'm more just quick and dirty, but that's because I only write generators. I don't need to write fancy programs. I write generators that program efficient. So my generator code is sloppy, but my actual outputted code is less sloppy. I think we're gonna end up here today, because I think we've made quite a bit of progress, and really there's a lot to do in the next episode. So I'll see you guys then.